I'm going to go over to Mark. And I will spotlight Mark for everyone. Okay, go for it, sir.
Okay, so we're actually going to try some sort of spinning superconductor experiment over here. And if I can get the scale to run, we'll actually be able to see if there's anything going on. I got some liquid nitrogen here at the lab. So we can start off with just a simple demonstration of superconductors. In here we have a small YBCO superconductor. And many of you have probably seen this, this presentation before. Let me go a glove or something. It is kind of cold. I almost got a burn before. That's better than nothing. And the superconductor over here, the YBCO, which is type 2, actually got quantumly locked to the magnets, and it's kind of floating around. Not doing that great of a job because of the foam is locking it in place. Or there you can see it floating. The next thing we have here, which is basically magnets with opposing magnetic field.
And Mark, I should mention that we can't hear you. I'm not sure what might be going on there.
Okay, is that better? Can you hear me now? Okay, perfect. Okay. Just hold on one second. We're still getting there with the liquid nitrogen. This is going to take a couple of minutes. It's a pretty large disk. So I have it inside of like a foam cup here, and I'm not sure if you heard this earlier, but the magnetic field lines in order to hold this disk in place, we got north in and then south in. It's basically alternating. This was a design that Jeremiah Pop suggested the other night. For a scale measurement, I actually have a NASA Huntsville mug that I got when I was down there. And I'm going to try sharing screen and getting the weight measurement of that mug on the screen. I had it up a moment ago, but it was we were running into technical difficulties when the measurement wouldn't really change much. Logger light, here it is. Tim, if you could unmute everyone or let people unmute, that will be helpful, because like if anyone has any questions, I can answer them in real time while the superconductor cools
Okay.
down.
Yeah, so I just enabled it to allow people to unmute themselves. And so let me see. It looks like Remy had some questions. And I guess guys just try to, oh, no, Remy, go for it, sir. Go for it.
Mark, how you doing, Mark?
Hey, I'm okay.
Yeah, we lost your sound just as you got out of the chair to do the second video. You lost all your description of what you were doing. Can you run it by us
Oh, okay.
again?
So what we were doing before is just giving you a that was a proof of concept of the Meissner effect, and we had the superconductor running along a little track. So it gets locked in.
Yeah, not that one. The second, we saw this one. You had sound up to this.
Oh,
one.
okay.
It's the
Okay,
second
great.
one. Yeah, the second one. We lost all description of what you were doing.
Oh, okay. So I'm still cooling off a superconductor over here. We're trying some sort of replication of the spinning disk experiment.
So it looks like a 3D printed wheel with 6 bar magnets positioned inside of it, or is there just one for now?
There's 6 bar magnets printed inside of it. The bar magnets are polarized axially, and it's attached to a motor base over here. This thing can spin pretty fast, faster than I would want it to spin. The mug over here is hooked up to a scale that is actually connected with via USB back to the laptop. And I'm going to try to do a share screen so I can give you the live data from my laptop. Let me see. There we go. Share screen. Okay, so you can see now you should be able to see both the experiment going on and the sample measurement. Now, I was having trouble before that that it wouldn't zero. Like it seems to be frozen. Yeah, and it seems like it's doing it again. This is an issue I was having earlier. Resetting it.
Jeez.
Can't get a measurement.
Like me with no microphone found, and you earlier with no microphone. There we go. Now it's moving.
Yeah, it's moving a little bit now. Let's see if I. Nope. Nope, I got nothing. It like works for a couple of seconds and then it stops working. Anyways, I don't want to keep you guys waiting too long. I'll just power it up and we'll see what happens. And
Mark, are you going to be okay spinning that? I don't want that nitrogen to fly out and get you.
I'm not worried about the nitrogen. I'm worried about the magnets, actually.
With them too.
I mean, yeah, this shit can really hurt me. The magnets can hurt me, not the liquid nitrogen. Oops, okay. It needs like a little bit of a startup.
I know. I want to make. Hey, Mark, can you make your thing bigger and make that any way to make that forceometer just a small window and then make the.
That's on Tim. It's not on me. The forceometer's not working. Not changing at all. I can blow some smoke over it, see if there's any upward smoke.
Yeah, I'm trying, but it's. Oh, there we go. Unswap the screens. There we go.
So Mark, if the forceometer isn't working, why don't I just unshare screen then?
Yeah, stop
I
sharing.
got it. No, I got it working, Tim. Just it's fine.
No,
I
the
got.
forceometer's not working at all. It's showing the exact same number even when I lift the
Yeah,
cup
that's
up.
fine.
So it's obviously not working.
We'll have to get something else.
I'm curious what Tony thinks of this this replication. Is Tony still there?
I'm here, being quiet. I think the superconductor is too small to see an effect.
One thing that's kind of interesting is we got the superconductor locked into the fields, and every time you turn it, like you see when I get the magnets over 60 degrees to the next polarization point, the superconductor wants to float up.
Yeah, it's acting like a magnet because it's pinned the flux in it.
Right. So I wonder what would happen if I got all the magnets spinning and held the superconductor in place. 1 second. Oh shit, this is cold. You get a better glove. 1 second.
Get the chemical gloves.
Yeah, we have them for a reason.
People were taking more, using more PPE for, Corona than this, man. You don't have a face mask, nothing.
It feels really weird.
Well, the superconductor is acting like a magnet, so every time it magnet field, you should feel it like going up and down as the field's changing.
Yeah, that's what it's doing. Pretty strong.
Yeah. It traps the field pretty well. Like I said, I mapped the field after trapping it once, and it's pretty strong.
Oh, it's vibrating pretty nicely.
Mhm. You're doing something a little differently.
Sounds like those the female massage toys. You can really get up there with the frequency as the RPM rises. Wow, it's a very interesting toy to play with. I think the scale measurement might be broken, so maybe later in the second half of the presentation, if I get that fixed by then, I'll do a rerun on it or just try a new scale. Because I do have a backup unit. So
the mug above the hanging mug was just to measure if there was a shielding effect or a gravity loss above it.
yes, yeah, because that's how Podkletnov claimed there was weight loss. It was measured above it. So I had the
Right.
mug over there, but the scale is not working correctly right now. And
Oh, Mark, Remy Remy put this in chat. He was wondering if you could improvise a balance with a stick and a lightweight.
So there was nothing in the mug though, too.
there was nothing in the mug. No, just a piece of ceramic.
Yeah. We did a lot of this stuff with rotating small discs. We never saw anything.
I mean, I could figure something out. It's going to take at least a half an hour. So
Yeah, well, we could try it later during open session.
yeah, we could try it again during open session. And by the way, I'm wearing the glasses again, not for the liquid nitrogen. This thing is 3D printed, and at the speed it's rotating, I've seen things fly off it that can possibly even like break skin. So it's pretty. Yeah, rotating large masses is dangerous.
Especially when they're cold. 'Cause
Yes,
it's more brittle. So
yes,
yeah.
that is true. That's why I have
Okay.
it.
Well, should we, do you want to go to, while you're working on this then, and Mark, thank you for
I
the
mean, if
presentation.
anyone has any suggestions or questions about the setup, I would love to hear them right now. This way we can work on it.
Okay, yeah, let's do that then. Let's do that. So here, I'm going to remove Spotlight. Let's do Q&A then. And anybody who has questions, go for it.
Suggestions, yeah.
Mark, I want to start with saying we definitely need to work on getting a hood, a vented hood to work in with like a face shield over the hood. To
Oh, we got one right here.
experiments. Yeah, we should build one right in that corner. I'm gonna make a trip plan to come down there at some point.
That's a great idea. I could put that on the lab to-do list. Also, while you're down here, we need there's like a faucet connection behind the CNC machine that needs to get hooked up.
The nitrogen tends to go to the floor because it's cold. So,
Yeah, I have it.
So just be careful that if your room's closed too much, you can fill up with nitrogen and you suffocate. But it does tend to go to the floor instead of up because of it's cold. I think nitrogen may be actually heavier than air too, as it goes down. We never had a problem suffocating or anything in a room like you have, but you just have to be aware that you can.
Right, we have an oxygen sensor to measure the oxygen levels in the room. We check that out every once in a while. I do like to air out the room a lot, and I'm particularly sensitive to very high levels of CO2. So, but I think this is different because this would be suffocation, lack of oxygen.
Yeah. Just be careful.
Okay, yeah, does anybody else have questions for Mark?
I have a question.
Yeah, go for it.
What did you expect to see from the meter? And is it something that you did before?
No, this is the first time I did it. I was literally epoxying the magnets onto this disc at the beginning of the session. No, it's not something I've actually tried before, and we try live experiments here for the first time. Everyone can see the results. But we were hoping to see weight loss. I wasn't expecting to see weight loss. I would have been shocked if I saw weight loss. And yeah, that's pretty much it. One note, though, is that the superconductor disc over here is not very well built. I think it was like a homemade project or something. It's covered in like tape. Here's a second one that I got from them. It's covered in this like tape, electric tape kind of material. And when I opened that up, I saw it was full of cracks. So it's not a single domain. There's a lot of domains in there. I don't know if that's good or bad for this experiment. Tony, was the disc made by NASA single domain or multiple domains?
The large ones we made, we never made one that wasn't single layered, so we didn't do a melt textured on this. But I did some small ones that were melt textured that were quite well. We also acquired about a 4-inch disc from Oak Ridge that was melt textured, and it was very, very good superconductor, but exposing it to the liquid nitrogen and the moisture that it collected, it just deteriorated over time, fell apart.
Okay.
Mark, another thing I think we should do is get a data acquisition device and, find a way to actively measure the temperature of our superconductor disk with like a laser, or some other device that I can take data and put it into a computer, and I'll build a LabVIEW program, and we can actually take live data on both the weight loss and the temperature and all these other factors.
I mean, that would be a great idea if we're getting weight loss, to definitely take all those measurements.
Yeah, we're just messing around until we get something. Then once
we want to see a result first before we start, going crazy for every single last bit of data. You want to see that there's something there before you start looking at every single leaf of the tree,
Podkletnov used a frequency around 3 megahertz. And that seems to be a magic number for this YBCO. We did some experiments that actually showed that the 6 megahertz cosmic radiation going through the superconductor actually turned into 3 megahertz radiation. So spinning this this slow may not ever see an effect from it. You need something that's going to give you some.
What kind of RPM would be looking for?
We'll figure out what 3 megahertz would be with your magnets passing by it. It'd be pretty fast.
Oh, okay. So that would be 6 times the. Oh my God. Yeah.
Well, what if you could put a 3 megahertz signal on it, right? Maybe you don't necessarily need to. In fact, I've been seeing stuff in chat where they're saying, and I think Podkletnov might have suggested this himself. Maybe rotation isn't required at all. Maybe just try putting a 3 megahertz signal on it and see if that does anything.
I would agree with that. I don't think rotation is that important. It's the flux pinning, the superconducting junctions, and the frequency that you put on are probably the 3 important things. And
One thing that I remember that Podkletnov said that the effect was greatest as it was slowing down or something like that, between 3,000 and 2,000 RPM.
I could agree with that because such changes tend to give you effects you don't see in a steady state.
That's pretty interesting. Yeah. So another experiment I wanted to try was to have the superconductor being held in place while just the magnets that it's flux pinned to are spinning. Like we saw before, just if we can get that weight measurement in as well, and see if there's any weight loss.
The magnetic fields, when they're locked into the superconductor, in fact, the magnetic fields are locked into a magnet. Even though you rotate them, the fields in the superconductor or the field of magnet won't rotate. It's the field outside it that rotates.
Right.
Okay, well, so let me go to Michael. Michael has a question, and then after that, let's go to Ken Griggs, our next guest. But let me go to Michael first for a question.
Okay, I'm waiting for him to come back. He's a mad scientist.
What's up, Michael?
Oh, not too much. So, first question. Maybe you need one of those $50,000 doers.
The one I got on Amazon for $1.99 is working just fine.
Okay. So my one question I have is maybe if you could design a kind of like a thermos jar which had a cold finger. You know, when I used to work on these, they used them a lot in the IR detector world, and basically you had this fancy doer, and it had a cold finger, a piece of metal, non-ferromagnetic metal that would sit. So you fill up you fill it up on the side, and then this thing you would be able to like clamp it in there, and you wouldn't have to worry about filling it with the liquid nitrogen and the nitrogen being thrown around, because it's contained in this cavity, and the metal plug that the superconductor is in thermal contact with it. We used to use a piece of indium metal to stick it to it, and that way you could rotate it around and you wouldn't have to worry about it. And then the other idea I thought you might consider is, instead of having a cup, you have something that has a low gravity compared to the ambient environment, like a balloon, for example. A balloon like a Mylar balloon or something that basically it's sitting there. It doesn't take a lot of change in mass for it to move. Follow? That big hunk of ceramic that you're hanging over there, it's got a lot of mass in it, and if there is any effect there, you won't see it.
The issue with a Mylar balloon is you're looking at airflows at that point. Very heavily affected by airflow.
Well, it depends on how far away it is, I imagine.
Yeah, well, you know, also do you think that could work the other way too? Because you've got more mass there. So if you have a gravity effect, it has more to affect as opposed to Mylar where it's so lightweight that maybe it's reducing the gravity, but you know what I mean?
Right. Well,
Yeah,
maybe
good point.
my point is maybe something different, like a metal balloon or something, you know, like a sphere, a hollow sphere or something like that. Just my idea is that you have too much mass there. You have a little tiny superconductor puck and you got this big mass that you're trying to move. Make the mass relatively the same magnitude, and then I think you can see the effects.
I mean, if it is a gravity shielding effect, you'd want the mass, and you're only looking at like 1% gravity weight loss or gravity shielding. You'd want your sample to be as heavy as possible so that you can see that, you know, get better resolution on it.
It's just an idea.
Yeah, something to try.
I'm guessing.
Okay, well, so let's go. Let me see. I think William Schramm had a question. So let's go to William, and then after that we will go to Ken Griggs.
Oh, wait, I guess I just had a suggestion. Maybe we get Cryomech to sponsor this experiment so they can actually like put a cryo cooler in there instead of liquid nitrogen. So you instead of asphyxiating yourself, you might just try putting a refrigeration unit there.
I don't know. This thing weighs a couple of ounces. How heavy is the refrigeration unit?
It's quite heavy, but nevertheless,
I guess there's your answer.
Something that you could operate. That's another core skill.
Okay.
Yeah, you got to weight light and small.
So let's do this then. Let's go to let me put it back on. So first of all, everybody, let's give Mark an enormous hand for his demo so far. Mark, that's an awesome demo, and it's wonderful to be able to follow up Tony's presentation by talking about that as well. So let me do this. I'm going to mute everybody out really quick. So if possible, I would like to get Ken Griggs in. So